Hey there, in this video we're going to talk about absolute value inequalities. So for example, if I have something like solve for x, or the absolute value of x is less than 3. So what does that mean? Now remember, back when we did for just absolute value equations, if I had the absolute value of x equals to 3, the absolute value means the distance between x and 0. So this says the distance between x and 0 is 3, and I think this was in the quiz. So what that means is if you have the distance between x and 0, so here's 0, so if the distance has to be 3, then that means you go to the right 3, so x equals 3 will give you the distance between 3 and 0 is 3, but you can also go to the left, so you could go to -3 because the distance here is also 3. So x is either 3 or x is -3. And so this is why when you solve an absolute value equation, you have two cases, right? The positive, that means going to the right, and then the negative case, which is you're moving to the left. So when in our case that we have the absolute value of x is less than 3, so this is saying the distance between x and 0 is less than 3. So as before, where it was exactly 3, we went x is equal to 3 or x is equal to -3. Now there's a range of values, right? So if I go, here's 0, where could x be if the distance has to be less than 3? So that means if I go all the way to 3, now notice that it doesn't have an equal, so I don't want the distance to equal 3, but just less than. So anything in here, the distance will be less than 3. And likewise, if I go to -3, not including 3 or -3, the distance here is less than 3. So what I'm going to have is that then x could be anything in that interval, right? If x is 1.5, the distance between 0 and 1.5 is less than 3. Right? The distance between x, because x is 1.5, and 0 is less than 3. The distance is actually 1.5, which is less than 3. So anything in here. So my answer will be that x can be anything between 3 and -3. So anything less than 3, anything greater than -3. So that will be our solution to this. What if I wanted to solve the absolute value of x is greater than 3? So how does the solution change? So let's go back to the number line. So the absolute value of x greater than 3 means the distance between x and 0 is greater than, so I'm going to say larger, just to change it up, is larger than 3. So I'm going to put 0 here. So where could x be? Well, I'm going to again go to 3 because that's my reference point in -3. And the distance, so where could x be? If x is still in here, notice that between 0 and 3, the distance will be less than 3. I want x, it says the distance between x and 0 is larger than 3. So I want x to live out here. So if x is 5, for example, then the distance between x and 0 will be 5, which is larger than 3. So essentially that means I want x to be greater than 3. And then here, so just as I did above, anything in here, the distance will be greater than 3. And then anything in here, right, if I'm within -3 to 0, so if x is anywhere in here, between -3 and 0, the distance is going to be less than 3. But I want the distance to be greater than 3, so we have to be on the outside of -3. So that means that our answer will be x is on this side of -3, so it's less than -3, or x is greater than 3. So notice how it changed the sign. So here we have x is greater than 3, right? So we keep the same sign, but when you do the negative side, notice how the sign changed, and that's because, remember, the further you are from 0, the smaller you are. And so that distance, well, in this case, we're just looking at the distance. So the further you are from 0, the bigger than 3 the distance is going to be. So it's x less than 3 or -3, or x is greater than 3. So in interval notation for both of these, this one is kind of nice. When we have a compound inequality, I'm just going to have -3 to 3. So that's my interval notation here. What about the interval notation here? So I can shade it. And these are not included. So my interval notation is going to be -infinity to -3, not included, or, so that becomes a union, x is greater than 3. So 3 not included all the way to infinity. So let's try something a little more complicated. So let's solve the absolute value inequality, say 2x plus 1 less than 5. So how do you solve that? So based on what we did above, so some of the things that we can say is that if I have something like the absolute value of x is less than c, what this means is that x is less than c but greater or equal to -c. Let me rewrite that better. This means -c less than x less than c. If you have the equals there, it's the same thing. It's just that then you would have the equals in there as well. So that's like our first example. If you want the distance between x and 0 to be less than the number, then you're in that interval. I call it kind of like the sandwich, x is sandwiched between the two numbers. Now, when you're doing the greater than, in this example, notice that we had our two cases was x is still greater than 3, or x is less than, so we flip the symbol for that second case. So if x is greater than c, what this means is that you can have either x is greater than c, so it's going to stay the same, or x is going to be less than -c. So when you do the negative case for absolute value, you have to flip the sign. And if you have the equals, it's the same thing, just with the equals. So either x is greater than or equal to c, or x is less than or equal to -c. So for absolute value, just like with equations, you have two cases. It's just that for an inequality, it's a little bit different when you do that second case. This is a less than, so we can just do the sandwich property. So I'm going to say 2x plus 1 then is less than 5 but greater than -5. Right, so that's what this says. This is this first one that I'm using. And now this is a compound inequality, so I can try to isolate the x in the middle. So subtract 1 from everything and divide by 2. So I'm going to have -6 less than 2x less than 4. When you divide by 2, I'm going to get -3 less than x less than 2. And so this is my solution. So our solution in interval notation would be x is in the interval -3 to 2, since things are not included. So let's try one more. Let's solve. So I want you to try this. 2 times the absolute value of x minus 3 plus 5 greater than or equal to 17. So go ahead and pause the video, try it on your own, see what you get, and then come back and unpause. So I'm going to keep going, assuming you're coming back from pause. So the first thing, notice that we have all kinds of things going on here, but notice that the rules up here only apply when you have the absolute value by itself. So just as in when you solve equations with absolute values, we need to get the absolute value all by itself. So isolate the absolute value. So that's our first step. So that means I want to subtract 5 from both sides. And I'm going to want to divide by 2 as well. So 2 absolute value of x minus 3 greater or equal to 12. I only subtracted 5, so I don't need to change the sign or anything. I still have the absolute value, so I don't need to do my 2 cases yet. The absolute value, and these are like brick walls. So you don't want to be taking stuff in, and you don't want to take stuff out of the brick walls. So absolute values, brick walls. You can't take anything in or out. So let's divide by 2 to get rid of that 2 in here. So I'm going to have the absolute value of x minus 3 is greater or equal to 6. And so now I have the absolute value all by itself. Yay! And so now we can use the property. And because my symbol is greater than or equal to is this last one. So we're going to be using this one. So x is greater or equal to c, or x less than or equal to minus c. Now I know that I wrote the properties with just x, but it essentially applies to anything inside the absolute value. So my first case is going to be, leave it as it is, right? So it's going to be x minus 3 is greater or equal to 6. Or, this is my second case, x minus 3. Now I'm going to do the negative case, negative 6, but with an inequality, we have to flip the sign. And now I solve these two. And just like before, we're going to add 3 to both sides, solving them simultaneously here. So I'm going to have x is greater than or equal to 9, or x is less than or equal to negative 3. So when we do that on a number line, I'm going to have negative 3 and 9. And because we have an equals, these are going to be included, so solid circles. And x is greater than or equal to 9. If you're greater than or equal to 9, you're a larger number, so we're going to shade to the right of 9. Or x is less than or equal to negative 3. If you're less than or equal to negative 3, you are to the left of negative 3, so we're going to shade to the left. And so in interval notation, we're going to say x is in negative infinity to negative 3 included, so that's a bracket, or, remember or, we use the u, the union, bracket, because it's included, 9 to infinity. And that's how you solve absolute value inequalities. So it's very similar to equations, right? You still, anytime you have absolute value equation or inequality, you need your 2 cases. It's just with an inequality, when you do that negative case, we have to flip the sign. So it's kind of like when you are solving inequalities in general and you have to divide by a negative, you flip the sign, and that's sort of what's going on. So isolate the absolute value first and then use the property. So one of the things, so if I said something like 2 times 3 minus 5x absolute value plus 7 less than or equal to 14, right? I don't want to say things are less than 14 and greater than negative 14 because the absolute value is not by itself. So you have to first isolate the absolute value and before you do the 2 cases. And the one other thing is that just as before with equations, if you have the absolute value of something, say I have the absolute value of x plus 5 less than 0, that's going to be no solution. Why not? Right? Remember, absolute value means the distance. So in this case, we're saying the distance between x and negative 5 is less than 0, but less than 0 means negative, and absolute value can't be negative. So this is going to be no solution. On the flip side, if I had the absolute value of x plus 5 greater than 0, well, the absolute value is always positive, so it's always going to be greater than 0. So this would be all real numbers because the distance greater than 0, well, distance is always positive, so the absolute value, so it doesn't matter what x is, you're going to always get a positive number here, so it's going to be all real numbers. All right, hope that helps.